All right, so this is super cool. Yeah, so to kick it off, thanks everybody for a pretty cool weekend. Forgive me for not being too much in the best of spirits, given a little bit of allergies. But thank you again for coming this weekend. It's really awesome again that you guys could come. It does mean a lot to me, again, being a native to Texas. So just a big shout out real quick, again, to the local organizers, the Rogers O'Brien guys, the Beck Group, and definitely our host here at Addison Treehouse for providing us such an awesome space. And then, of course, all of you who came in town and your companies that sent you and things like that. So thanks a lot. It's definitely been a fun weekend. So with that, you know, it's the weekend has been cool. Everybody's a winner, but today we're definitely going to, well, probably everyone will be a winner, you know, but it's definitely going to be a very cool day and a great weekend. So with that said, we're going to go ahead and kick things off with the electrical safety power flow team. So team electrical safety power flow, please come on up. Do talk into the microphone and you know, so that way we have our judge that's logged in and the judges here can hear you.
Something to say. It's on the other side.
So if you can, if all you guys could just introduce yourself. This is pretty much for everyone. Just introduce yourself. Tell us a little bit about your team. And don't forget to hit those points.
Good afternoon, everyone. My name is Sonia, and our team did the electrical safety power flow. That was our goal for this hack. Our team included Raymond, who was not able to join us up here, but he was our lead programmer with the Beck Group. We've got Mike Cross, Jordan Mansfield, Chris Miller, Tyler Murphy, and Leo Papart. And we joined efforts, electrical subcontractor, the Superior Group, and the Wayne Turner Company, GC. So it was great to work on the same side, as usual.
As usual.
So our problem, during construction it is important to know what electrical equipment is on and off, the status of it, as well as what that equipment feeds in order to safely complete the building. There's a lot of times where you go up to a panel and you're not 100% sure, you should be, and there's a whole lockout, tagout process that goes into that, but there is room for accidents, and it's always our goal to reduce those accidents as much as possible. So how can we efficiently compile this information and analyze it? So, you know, what panel feeds what, and how can we find the best way to organize that information for everyone to access. So the current solution is to scrutinize the drawings, take a look at the one-line diagrams and the panel schedules, and gather all that information together in either a power flow matrix, a feeder schedule, and then use that to create your lockout tagout plans. An example of what some of these look like. The power flow matrix, for us, one of our examples was you're taking from beginning to end that lineup. So you'll have over 1,000 rows of data. This is just showing approximately 120 of them, but I have a laser, but you can see that at the very beginning on the far left there's the main panel that feeds it, and then it breaks off into smaller and smaller panels, and then eventually the branch circuits. It's hours of data entry, hard to visualize, it's difficult to verify because there's a lot of manual entry, room for error, and it's constantly needs to be updated. So every time you get a new drawing issuance, you have to go through that process again. And those panel schedules on some projects, they change a lot. This is an example of a feeder schedule. We had to zoom out just to try and show just a portion of that information. There's so much that is captured, and this is more on the electrical side. So the subcontractor, they will put this together. They're doing the same scrutinizing of the information, going through it and redoing all the work that in some cases you might even have in the front end in the model. So our hack solutions, we mainly focused on trying to extract that data. So Revit was our main source. In some cases, you'll get a very smart Revit model that has the panel schedules, that has some of that logic that connects all those different panels together. And that was the goal, is to take that information and make it useful. So our solution was either navigating that information with an Excel or a Google spreadsheet, so getting that information out of Revit or finding some other way to manipulate that data and finding a way to then take it into a format that we could use. The other option, which we also worked diligently on, was the mobile-friendly searchable web interface. This could then be taken to the next level using a QR code. You could then go up to the panel, you have these QR codes, and they get you to that web interface. The benefits for the general contractors, electricians, building maintenance, mechanical, there's so many different avenues. So if you're going down to the basic level of a RTU or some piece of equipment on the tail end of it, the mechanical equipment, you can see what's going on with it and be able to see, okay, if I want to turn this off and be able to work on it, where do I need to go? And with that, I will pass it on to Mike Cross.
All right, so the big thing was data extraction. How do we get this information? So ideally, you would have a Revit model that an engineer or designer already put all that information together. It already shows what's tied to what. That information is there, just how do we get it out of the model? Another thing is a lot of our guys who do a lot of this work might not be as familiar with the formulas you can do in even just Excel or a Google spreadsheet. So how do we make their lives a little easier so they're actually gathering less data? So again, if there is no Revit model or it's an incomplete model, everything's not linked together, we basically have to pore over the one-line drawings, really scrutinize all that data and find out what's directly feeding each piece of equipment. So one thing we thought of is if we already know what's directly upstream of each piece of equipment, we can use a formula, whether we use like an array or a list mixed with a match, to automatically just search a range and automatically get what's downstream of each one of those panels. We never quite exactly figured out how to mine that data, but we know those options are out there and it's just figuring out those formulas. So again, the ideal one that we spend a lot of time with, and thanks to Raymond we're able to get, is extract the Revit ODBC database information, utilize the ties that already exist in that database, and basically just combine the different information so you can pull out exactly what you need. So this is an example of when we pulled it out into SQL. So you can see on the left, again, kind of small so you can see everything. But on the left you have that tree, and that's every single little database or information that Revit already pulls, and that was a pretty large list. So you can pull out rooms, electrical equipment, mechanical equipment, etc. So the next part is how do we search and analyze it? So this was an example of just something quick I put together in Google spreadsheets. So if we already have that list of data, you can automatically just use like a drop down or a data validation to choose, if you have multiple projects, you would choose a project and then choose the piece of equipment that you want to look at and figure out, what's it feeding, what's it being fed by, maybe the room it's located in. All that information is there, you just need to be able to pull it out. And this was an example of kind of a power feed, so this kind of looks like a one-line diagram. So say, you don't have the drawings in front of you, or the drawings are really big, it's hard to look at on a phone. You could just search for that specific piece of equipment and you only want to know what's directly above it, directly below it. Then you just punch in that piece of equipment and it'll show you that information automatically. And with that, I'll turn it over to Jordan.
Alright, so kind of a continuation of the whole process here, what we've been talking about. One of the last pieces of the puzzle would be able to access that data from the field. And so, there's numerous people working on a job site. To have that information readily available can really speed up a lot of processes and save time and money. So our idea was to place a QR code on each piece of equipment out in the field, and you'll be able to scan that with your phone with a simple QR code scanner, and that'll take you to that the interface that Mike was describing, where you can search that piece of equipment, that panel number, that item, and it'll tell you exactly what what it's fed from and what it also feeds. So we realize with all of this that there are some potential failure points. This could help aid the next round of development with this. As Mike and Sonia both mentioned, the Revit model may be incomplete or not have all the relationships there that you need. So when you extract the data, it might not be as beneficial as you would like it to be. If you don't have internet access in the field while you're on the job, if you're on the construction site, we run into that issue a lot on our project. Just bad internet connection or a bad cellular connection. You might not have a smartphone or a phone that has a camera or scanner capabilities to scan those QR codes. Incorrect labels on equipments or drawings. That's a frequent mistake that happens quite often. So. And then also, if items in the field weren't installed correctly to the plans or the specs as they should be, that would also create an issue. So some of the ideas we wanted to expand upon, just a quick run through here, and then I'll have the rest of the guys kind of speak about them in more detail. But have a power indicator kind of interface where you can see exactly what item, what piece of equipment has power, whether or not it's turned on or turned off. Have a procedure in place with a user interface that shows lockout, tagout, who locked out this piece of equipment or this panel, when and where and why. This could also have applications towards the commissioning side of things. If a piece of equipment or a panel has been fully tested and commissioned. Facilities management also would be one application. How can we use this information from the model to really help the end user? And then also just talking about some other data collection tools if we don't have a model. So with that, I'm going to hand it off to Chris.
Hi. So another really important aspect of this is making it easy for the end user to interact with. So we would like to have a search function as well as a visual representation of what the power status is. So here we can see green, everything's energized. You go through and you can start seeing what happens when you start de-energizing stuff. Panel 1's off, the rest is off as well. Then you have a generator added in and it's not energized because it doesn't need to be. Then the main utility would go off and you'd be able to see that most of the power's off, but the generator kicks in. And yeah, that's it for that. So I'm going to hand it off to Leo.
Hey. All right, again, quick shout out to Raymond. He was a tremendous help to us. He should have been here to kind of give the presentation with us, and also our shy friend Tyler here, who's not going to talk, but want to make sure he's in there. So lockout, tagout, safety on the job site's obviously a huge importance factor to that. Who locked the equipment out, contact information to that person, what was powered down, why was it powered down, how long is it going to be powered down. All those factors are huge and they impact everybody on the job. So being able to identify what those are and having a system in place to easily retrieve that information. So the concept is everybody would have kind of like their own profile for the project to be able to interact with the system. They would be able to log in, all their credentials are already recorded, their lock numbers, who they work for, what their contact information is, so it's not something that anybody can really forget to do. If they walk up and they scan the information and they can update the information to the specific equipment that they are locking out. And again, all that information would be already recorded from the beginning of the project or when they hit the site. So that way they don't have to spend a lot of time trying to enter data, or they're just, rubber number type scenario where they're just putting information in to get to what they need to get to. So it kind of would follow the same process as far as equipment that is not energized or that hasn't been turned on yet or has been turned on yet, that they can go through and they can lock it out, and that visual representation of what is locked out, what's affected downstream, so that everybody's aware, and then also be able to tell who that person is so that we can make sure that we can get that back online if necessary. So The lockout, tag out, the safety process is definitely a huge application of this, as well as being able to track what is energized, what's not energized for other safety reasons as well. So, commissioning, that you?
So like we were mentioning earlier, again, commissioning, there's a lot of testing and things need to get done in order to make sure that equipment's ready to be turned over, does it work properly, all that. So if we were able to link each piece of equipment with actually its own URL, so it would have its own QR code, you can sync up to that just by walking up to a piece of equipment and okay, I'm going to complete this, or I notice this is done, so I'm going to check it off. So you go up, scan it, check it off, it automatically brings you to its own code and it's done. And again, that's already linked to the power, any kind of other sign-offs, you got permits, any other information. And then this goes hand in hand, you can turn it over to the client, the end user, with their facilities management, so they can walk up, do the same thing, scan the code, and then they'd be able to see, when's the last time this got a new filter, when's the last time this had maintenance done, hey, this isn't working right, do I still have a warranty on it? You could also have maybe the installing contractor's information, all sorts of other information. If you really want to get fancy, all of us here pretty much work in BIM. You can link this up to Navisworks or Revit, so then even if they're just in the model, they already have the link that brings them to that equipment and all the information they need. Sonia.
So the other step, just in case you can't get all this information out of Revit, which granted has happened to all of us, we can't get the information we need sometimes. There's also another aspect that we briefly started looking into, but we definitely want to try and pursue a little more. So those single line diagrams, kind of like the examples we showed you, having a way to analyze those as well as the panel schedule and be able to take those relationships between the panels and make sense of it. So we have OCR, we have other text recognition softwares. The next step is finding ways to recognize relationships as well. Basically making a table again in another format, or a flowchart a flowchart. And then that fills in the blanks for the times that you can't get that information from Revit, you still can go back to the drawings and be more efficient with it. With that, we'll do a real quick demonstration of some of the output, and thank you to our hosts, thank you to the sponsors, the presenters, and Addison Treehouse. Mike, do you want to scan that while I do?
Right, that's basically just that's basically just a scanner. So if anyone, if you're watching this presentation online or anything, that'll bring you actually to the Google Drive page where we have all the information for everything we've worked on, including what Sonia's pulling up right now. So you can take a look at it, see what information you can gain from it or what you can utilize it for.
So this is very basic, very just the beginning of the process for us, but it's a basic web interface. You have your home, you log into this, and it has a search feature so you can find a panel. The QR code will bring you up to this, and then you can find whatever panel you happen to be standing in front of at that moment from there. Not quite a lefty. So then it tells you service A2 switchboard, that is the panel you're currently looking at, and from there what's feeding it, and here we are, so this is your 2. So from this panel to where we are now. So if I click from, that'll take me to the next step up. So the future of this is trying to get it into a flow chart so it's a little more user friendly, a little more visible, but let's try this one. So yes, then it takes you to service A1 switchboard. And the other step was being able to edit the status of it. So you can say, if it's unchecked, it's off. And you can come into this, edit it, change the status to on, update, and it will check everything that panel feeds down the line. So that way you know, okay, if I'm working on that rooftop unit down on the end, I've got power to it now, so I need to be careful. Versus if it's off, you can't turn that RTU unit on or the panel that feeds it if the one right above it is off. And that sums it up. So thanks for hearing us out.
All right, so I am Team Cyborg for right now, just me. But I chose to work with the Emotive Epoch Plus. It's a neuroscanner that gives you a little bit of EEG readings, and then it has some built-in functions for what they call expressive, affective, and then cognitive abilities. I'm trying to read from your brain. Right now I'm not getting a terribly good signal, of course, now that it's time to present. Like if I sometimes hold it close to my head, you start getting, like all these little black nodes are supposed to be green or yellow or red or something, but we'll see if we can get a little bit of action out of it in a minute here. But basically the way it's set up is, you just put it on your head and it's got little sensors. This one has 14 sensors on it that reads what's happening in your head, hopefully. And so the expressive suite is the part that I worked on because it was sort of the easiest to get immediate feedback from and get an idea of what it's doing. A lot of it is because of this happy little robot guy here. He's supposed to be mimicking what you're doing, so if you're smiling, he's supposed to smile. As you blink, he's supposed to blink. It's got eyebrow movements, but because my sensors aren't picking up super well right now, if I hold it really tight against my head, sometimes they'll pick up and get a little more. But when I go into the active demonstration, I'll just put the mic down and try to hold my head. So the expressive suite is things like where you're looking, if you're blinking, raising eyebrows, clenching teeth, smiling. The affective is supposed to give you excitement or calm states, engagement or disinterest in meditation. Right now, again, I'm completely mellow on everything. And then cognitive suite, I think, is going to be the really interesting one because that's when you start training sort of thoughts to do something. So, there's sort of a neutral, calm mind state where nothing happens. And then they've got a couple of examples, and they've got this little floating cube that you can train to push or lift or pull or rotate. I trained a few, like pushing and pulling the cube closer and further away from me as sort of a test of it. And then they also have a gyroscope so you can sort of move your head and sort of get that data, and you can use it as a mouse if you wanted to, which is a little tricky if you're trying to get the right spot to click on. You're sort of moving your head around all over the place. But I mean, that's sort of the tool, but the sort of reason why I wanted to try it is because we were working on a stadium at work, and we've been getting a lot into the whole shading of the stadium, and is it going to be an active shade? Is it going to be just close the roof and just be done with it? And of course, the client wants to be able to open the roof and close it when they want, which usually means closed a lot of times, but just in case they want to open it. So we thought about having an active sunshade that, as you start becoming uncomfortable, if you have too much sun on you, that you can just sort of think about shade, and it'll shade your particular portion of the stadium, of the seating bowl, and hopefully not affect the field because that's apparently a no-no, at least while the game's going on. So that was sort of the original idea, and then we thought, well, we can try one of these and see if we can get it to control something. But even aside from controlling your physical environment around you, you could also use it for virtual reality. One of the big problems about virtual reality is sort of understanding the experience of it. You can feel a little nauseous when you're working in it a lot because you have this sensation of moving through your eyes, but your body doesn't feel it. So seeing the discomfort or comfort of someone, as far as just being immersed in the environment, or just how they're affected by the space that you've designed, it's another area that we want to sort of look into. But as a basic example, my first thought was, well, I just need to be able to sort of read the data and do something with it. So I started with a little simple example of a cube that can grow bigger or taller or shorter. It can twist because you have to have twisting towers every time you do something in a node-based scripter, it seems. And then, and I think that's controlled by my smile factor. It'll actually duplicate itself if I blink. So hopefully this will actually do something. So it's broken into two parts. There's two parts to the application right now. One is just reading the data from the headset and writing it out to a file, and then the other part is reading it from the file and then doing something with it. So I'm going to launch this thing, and now it's reading. Of course, the sensors still aren't there, so let me start it up on here. So I'm going to push true. So you can see it's doing something, even though it's not necessarily reading what's happening for me. It's still trying to read something. and it's a little buggy still, but I'm going to put this down and try to hold it to my head and do something purposefully. Alright, so supposedly if let's see if I have a signal. I do have a signal now. So if I smile, it's supposed to twist or crash. If I blink, it's supposed to double itself. So you can see a little bit of that happening. It's obviously not really trained quite right. I spent all weekend just trying to get it to communicate and not training myself. Thank you. So it's not quite there yet, but I think there's potential if you can understand the data. And this is a very limited sort of reading the data and trying to understand it. There are other ways you can read the raw EEG data potentially and do something with that, and even write it out to a database that you can sort of review someone's experience over time and see like how it affects how they move through a space or how they understood something. So that's kind of where we'd like to go with it in the future, is like get a little bit more fine-tuned data out of it, so that we can cognitively do something like purposefully, I guess. And we've tried to set it up in a way to start with, at least, that it's not sort of platform specific, because we don't all use Rhino. I have like a really simple Dynamo file that sort of works, that should hopefully change, maybe. Sometimes it does, sometimes it doesn't. But this is just reading, and it's not doing any automated. So hey, it came up with a number. So it is sort of doing something. It's not active yet. You have to sort of push run every time you want to do it. So the next step to this would be to sort of make it where it's active and constantly reading and constantly writing out values. And of course, give you more than just one value. So eventually it'll be sort of something that spreads to any software we want to use, whether it's architectural or whether it's visualization, or we just want to write it to a database and look at a chart of how it's been, how someone experiences things. But that's all I got. I want to say thank you again as I leave to AEC Hackathon. It's been a great deal of fun, and Treehouse, Addison Treehouse, thanks for letting us hang out here. It's a great space. Thanks.
Hi, my name is Ron Dagdag. This weekend, I didn't do a lot of the presentation, and I do apologize. I get scared every time I talk to the microphone with the camera also. But what I wanted to do this weekend is to be able to test and develop a controller for the VR experience on this view and data API that Autodesk is working on. So I tried testing their view and data API, their VR stuff for the past few days, and pretty much what it is kind of like they have where you can control the 3D. So pretty much using Google Cardboard. One of the examples that I was playing with is where you can view, and just sometimes it's easier to show you what the technology is. Pretty much it uses, you can use it in your phone. You go to vr.autodesk.com and be able to go to like different places and go through that. So so what I wanted to do this weekend was to use these Leap Motion. Leap Motion is a controller where it would detect your fingers, and also be able to know how many fingers you have, and be able to control a little bit on that. And then also I was playing with the Mayo, where it's also another controller that you can use without the camera, that it detects kind of like EEG also, or from your fingers, and it would do that. Actually, see the screen. So let's try it. Hopefully it works. Okay. So here's the application that I was testing, like the ones I was showing you a while ago. See, click start. So this is a model that we uploaded through that Autodesk. So what I wanted to do is when I use this leap motion, when I open my hand, it'll move. And also here in the cardboard, you can actually see the same way too. So you're actually streaming. It's the same model, actually streaming to multiple videos. So technically, what I was trying to do is, if you're trying to show a 3D model to a group in a certain location, and have a main controller to be able to control the movements of each one of those users. So be able to do that. And also sometimes, sometimes it gets lonely. So what I wanted to do was to set up a way where, let's see if I can go over that to reload again, to where you can send messages on this VR. So it actually sent a cat, and his name is Steve. And so, and also you can actually see it in here. So multiple users can see the cat at the same time.
Oh, whoa. Yeah.
So that's the idea, be able to send messages from the server. And then of course it gets. But anyway, that's pretty much what I wanted to do in the next is, I was experimenting, but I wasn't able to finish it. But I have, we're talking about makers yesterday, and I have this. I was trying to connect my, this gloves that has this bend sensor. So in order to connect the same situation too, where you have a glove, it's just using little bits to connect to an Arduino, and based from, it tells you that it's not just sensor. You can have different sensors that you can control the VR. So the idea is be able to connect through the Arduino and be able to send messages. You can have a robot in the future, or some other sensor that you can connect through it. Anyway, I wasn't able to finish, but I just want to let you know though. So anyway, that's it.
Awesome.
Thank you very much.
Yeah, that's
Oh, it's wonderful to be here. So what we were trying to do was this real life problem of going into these job sites and trying to see, the project as it's progressing. We have people out there taking pictures all the time, different rooms, and they sort of put it in their folders, and it's a nightmare to sort of, when you want to search it by room, by location, or by date, how do you do that? So when we came into this AEC Hackathon, Rogers O'Brien and Balfour, we were looking at this as a real practical problem or frustration that we deal with on every single project and how we can solve it. So we came with these four goals of being able to develop a multi-platform web app for project punch list photos or for progress photos, but be able to browse it by location and have support for all these, 360 cameras, for a lot of the cameras that are on the drone as well. And I forgot drone for a second. And be able to automatically location tag. So that was the biggest sort of challenge for us this weekend, to come up with a hack for that. And then also to, kind of jazz it up a little bit, be able to, once we have these, experience it in different forms too. So the 360 photos, be able to experience it on the Oculus. So I'll give it up to Joe, and he can talk us through the technology.
Okay, thanks, Sonali. As Sonali mentioned, this is a big problem. Lots of photographs being captured on site, taken at all different times by different people. And so what we look for is a place where we could put those photographs, where people could upload them to the cloud, and then where that information could be overlaid in some sort of map or plan. And so in order to accomplish that, we used two different systems. We used Flickr, which you guys are probably all familiar with, photographer's dream spot to put all their photos, and then we also used Google Maps. And so using those two programs' APIs, we combined the two together. And so the user could either use their regular phone or a drone or a 360 camera, take a picture. So that photograph could be captured from within the Flickr app, or it could be captured outside of it and uploaded to Flickr later. If they're doing it inside the Flickr app, they can actually title it. So they can add some data that would be available later. Thank you. So there we go, we got our image posted, it's uploading to Flickr. And then the idea is that that information would be added.
Man,
Sure.
yeah, help out there.
Thank you, sir. Thank you. Mighty kind of you. All right, and so then we've got our Flickr account online where all of our photos are being stored. And you can see we've got some 360 shots. We've also got some aerials as well as some shots taken indoors just from a cell phone camera. And then all of that goes and is overlaid onto our Google Maps. So here it is. We've got our Google Map. We've overlaid the floor plan for the building that we're in today, the tree house in Addison up on the level 2. And those markers represent the photographs that are taken. So there's a shot from the classroom. We've also got one of the 360 shots here. So you can see that's been added as well. And then we've simulated a drone image to show what that would do. But basically any image with GPS coordinates in the EXIF data would be populated onto the map. And so some of the challenges we ran into were that GPS is not terribly accurate. So another shot we have is way over here. You can see by the exit. That's not where those couches are. It's funny, that was actually out of bounds, and it's also out of bounds. I don't know if you guys appreciate the irony there, but anyway, so that's what we've got. There's still a lot of things that need to be worked out. That the GPS problem can be solved. The Flickr API allows you to interact with the GPS coordinates and send new GPS coordinates back to Flickr. So what we'd like to be able to do eventually is to make the app where the user could reposition the photograph to the correct location, and that data would be sent back and updated to the photo in real time. So we didn't get a chance to show that, but the fourth and final thing was to be able to view the information on the Oculus, and Sonali was working on that. And I don't know. I'm going to show you guys what she's going to see when she puts on the Oculus. So she's got a 360 photograph loaded in. And you can see that she can look around using the head tracking on the Oculus.
This is real frustrated with the code.
That was JavaScript debugging there. So got the whole whiteboard too. That's pretty cool. You know, the great advantage of the 360 camera is getting back to the office and realizing, man, I didn't get a shot of that, or the 360 camera just gets everything in the room so that you capture kind of all points. But so we were able to accomplish all 4 of our goals. It was a little bit of a hack to get there, but at the end of the day, we were kind of able to create what we wanted at the beginning of the day. So our other 2 teammates, Mark and Chris from Builders Plus Construction, weren't able to be here today, but I wanted to thank them and you guys for letting us present today. Thank you.
Not so much of a entry into today's hackathon prizes and challenges, but just really just an update. My coworker Brendan and I, when we were in the New York hackathon in January, we're working on the Project Tango from Google, and this thing is a handheld scanner, kind of on the Kinect PrimeSense technology, structured light scanner. So we've been developing this, some of the code to run on that. But what we wanted to do was pair it up with a RTK GPS sensor that we got from Swift Navigation. So this is basically a whole mess of stuff. That you have a pair of these that give you centimeter grade accuracy for GPS. So the idea would be that we hook this thing up to a computer, and kind of as a base station, and then the other one goes on the back of the Tango, and you can walk around with the Tango, and then the idea would be that you get more accurate GPS than you can get from this device, and then we'll take the point cloud data that comes off of the device and basically rewrite the GPS data that we log from this other sensor, so that we can register the data a lot cleaner. So this weekend, the main thing that I got accomplished with the help of Frank really did all the work, was from Polyprinter, who's graciously printing some other things for us in the back right now. It's basically a kind of a case holder kind of thing. So this case will fit around the Tango, and then in the back of it we've glued on a Pixie holder. And then Malcolm and I were trying to get the Pixies to actually work. So we got them working in kind of single device mode, but we weren't able to get it working yet with the two devices to talk to each other, where then that's when you get the centimeter grade accuracy. So you'll have to stay tuned to the next hackathon or subsequent ones to find out where we go.
Right on. All right, well, cool. All right, well, welcome back from the break, everybody. So the moment that everyone, of course, waits for is who are the winners today. So before we get to that, again, a big shout out to our local sponsors, the Beck Group and Riders O'Brien. A round of applause, please, for these guys, man. They really made it happen. Todd, Joe, seriously, guys. Thank you. Brian, whoever Brian is. Also, shout out to the Addison Treehouse, Launch DFW, the Cohab space in Shreveport as well for helping us kind of promote here to the locals. Also, a big shout out to Polyprinter. Yeah, the Polyprinter group, the guys, for bringing their awesome 3D printers and things like that. So thank you guys for that. Also for printing our AEC Hackathon beer openers. That's pretty cool. So thank you there. And then, of course, a big shout out to our AEC Hackathon community sponsors. Thank you, New Forma. Thank you, Autodesk, Chrysler and Associates, Unity, Idea Builder, and others. There's a lot up there to thank. But for those that really participated. And so now the moment that everyone is waiting for is where I don't announce the winners just yet. So now that I have your attention though, I am just going to say, first of all, show of hands, how many people had a good time this weekend? Awesome, okay. Thanks, man. How many people would do this again? Okay, awesome, full house each time. All right. All right, so with that said, all right, so starting off with some of the prizes here, forgive me. All right, so for the Autodesk hack, which was the best one for the best app that used the Autodesk 3D and 2D web API, that goes to VR Steve. VR Steve, come on, don't be shy, man. So your t-shirt, and then that is your ticket there to follow up with Mikako as far as the Pebble Watch. So we have that there to give away, and then the next prize to give away we have is from the Beck Group, which was their Emotive, which is a Pebble Watch, and 150, and that goes to Team Cyborg. Awesome. Well done, well done.
Awesome.
Brian will take care of that as well as Mikako. Congrats. All right. And all right, and then the three categories that we had. So the best project that solved the biggest AEC problem goes to, drum roll please, the electrical safety team, Team Electrical Safety. So come on up. Thank you, man. Thank you.
Thanks from all of us.
Awesome. All right. I saw you peeking. And next category, because how many people in here made their stuff open source? Raise your hand on GitHub. All right. Yeah. All right. So, that one, the best, most ready to use application goes to Capture Map. Where's Capture Map? Where the Capture Map goes? Okay. Thank you, good sir.
Yeah, thank you. All right.
Awesome. And that's just wadded up paper in there, by the way, guys. And dream big, dream big. Share that with your group, though. We're all friends until this time, right? And then the best overall project, the last one, again, drum roll. Team Electrical Safety. Deja vu. Awesome. Okay, so that concludes the hackathon. Yeah, so that was kind of anticlimactic in a way, right? But anyways, but thank you guys, everyone, for coming out. Again, this is always awesome, insanely surreal. So please do connect with the rest of the community on whichever social media outlet you like. We have them all: Facebook, Twitter, LinkedIn, things like that. Also, feel free to get engaged and whatnot. Feel free to send me any recommendations that you have. And coming up next, we do have Southern California. So if anyone is interested in coming to that one in June, please just give me a heads up. That will be the weekend of the 27th, that last one there. It will be in 2 locations, so make sure to check it out. Don't make me laugh. And so thank you again to our judges. Again, thank you guys. That was a tough decision. And Chris, who's not on the thing anymore. So thank you again, everybody. I guess this is where we will just please give yourselves a round of applause for being awesome, and we'll see you next time.